Enormous, greater than the massive Jupiter with a measurement of right around 140,000 kilometers, the lord of our planetary system is so enormous that the Earth would hypothetically squeeze into it more than 1,300 times simultaneously. The colossal gas giant is around 2.5 times more gigantic than the wide range of other 7 planets in the planetary system combined. However, did you know that the planetary giant is a real Speedy Gonzales? Despite this truth, Jupiter only needs slightly less than 10 hours to turn around its own axis, making it the fastest rotating planet in our home world. But beside its enamoring magnificence, Jupiter is also the scene of giant storms and lethal radiation. What mysteries lie stowed away beneath its thick clouds? What do we know about the Great Red Spot, which is bigger than Earth and whips across the planet's outer layers at a crazy speed of up to 680 kilometers each hour? And overall, how should our own planet never have formed if Jupiter hadn't been rampaging through the solar system like a frenzied berserker? In the beginning, was Jupiter? Well, basically, that applies to the formation history of our planetary system. A couple of years ago, scientists at the University of Beast were the first to successfully determine the genuine age of the imposing gas giant. However, since the heavenly body has no solid surface and thus can't provide rock tests, the specialists had to take a little diversion in their age assessment and make their determinations from shooting stars. The main point, however, was the realization that Jupiter had grown to 20 Earth masses in under 1 million years after the formation of the planetary system and that its development was completely finished after another 3 million years. By comparison, the Earth, whose mass is multiple times more modest than that of Jupiter, took a walloping 100 million years to reach its planetary finish. And keeping in mind that the solid divine body isn't just the biggest but also the most seasoned planet in our home system, it was once formed from the dust and gases left over from the formation of the Sunday April 6 billion years ago, a stock of material that is too reflected in the formation of Jupiter. Very much like the Sun, the gas giant is primarily made out of hydrogen and helium, which unexpectedly also explains its relatively low mean density of 1,330 kilograms per cubic meter. However, despite the fact that the Sun and Jupiter are famously cut from the same material, there is now an average distance of 778 million kilometers between them. Exhaustively, the double XXL planet orbits past the asteroid belt between the orbits of Mars and Saturn, and thus takes only under 12 years to circle our central star. Well, rigorously speaking, that is not altogether right either since, supposing that we are very careful about the facts, Jupiter does not orbit the Sun by any means. But what is implied by that? Well, to figure this out, we need to bring a little diversion into the universe of barycenters. The barycenter describes just the center of mass that planets and stars orbit together. This is generally closest to the object with the greatest mass, and since the mass of the Sun is multiple times more significant than that of the Earth, the barycenter for this case is extremely close to the center of our mother star. However, as already mentioned, Jupiter is fundamentally heavier than our home planet, and as a result of this, we find the center of gravity of Jupiter and the Sun not at the center of our home star but right outside the outer layer of the Sun. Jupiter wanders off track. As a general rule, the greater the mass of a body, the stronger its gravitational pull on another body, and since Jupiter has a lot of mass, as referenced, we are talking about a significant degree of around 318 Earth masses. Its gravitational power impacts the design of the solar system in various ways, and that starts right at home. We now know of 95 moons that are bound to Jupiter's gravitational handle. However, that is not all. The subglacial sea of Jupiter's moon Europa is even associated with harboring extraterrestrial life. Anyway, further examinations should show how much this astonishing hypothesis eventually matches reality. So far, the gas monster has been the focal point of test-based research missions and flybys multiple times. In fact, the NASA probe Juno is still devoted to the task of investigating the Jupiter system exhaustively. What's more, the scientific relief is already on its way. The ESA probe JUICE set course for Jupiter on April 14, 2023, and is scheduled to arrive at the gas giant in July 2031. Up until this point, so mission-focused. But if we now turn our attention to the strict fascination of the gas giant, we see that its gravity surpasses that of the Earth by more than 2.5 times and that Jupiter, consequently, also acts as a kind of natural defensive shield. All in all, due to its impressive mass, its enormous gravitational field diverts comets and asteroids that could otherwise wreak havoc on Earth. In different systems, however, the closeness to such gigantic planets isn't always an advantage. One research study concluded that the attraction of the planetary giants redirects risks and also sometimes slings smaller planets out of the habitable zone. And speaking of being catapulted out, Jupiter too has a history as a gigantic wrecking ball. Scientists now suspect that the gas giant was initially formed multiple times further away from the Sun than its current orbit suggests. Additionally, there have long been signs that Jupiter even briefly moved into the inner planetary system, and in doing so, on the one hand, it caused unmatched chaos, and on the other, it empowered the Earth to form. The corresponding simulation by the researchers showed that the gravitational shift of Jupiter's relocation carried huge amounts of debris and planetary building blocks with it. We are talking here about planetesimals up to 1,000 kilometers in size and a total of 10 to 20 Earth masses of material. But it's in the nature of things that this planetary stroll of a somewhat different kind did not stay without consequences because it really triggered a genuine chain reaction of asteroid impacts, which obliterated larger planetary cores and made a huge portion of the debris dive into the Sun. The once exceptionally thick growth plate close to the Sun was, therefore, severely dispersed in the impacted region, and the situation only calmed down when Saturn formed farther out and Jupiter reversed its migration. Due to this, at the end of the day, Jupiter's passage cleared the inside of the early solar system empty and thus cleared the way for the second wave of formation of small rocky planets. Our Earth was also among them. However, this situation is also ready to provide an explanation for the irregularity of the solar system because in hardly any other known system do the gas giants start as far away from the Sun have as little gas as our own. Rather, most extrasolar gas giants or super-Earths orbit their host stars very closely and rapidly, and they often take only a few days or months to complete an orbit. Why does the Great Red Spot shake? But if we now distance ourselves from the violent history of Jupiter and instead explore its optical appearance, we quickly notice the unusual development of the planet. What from the outset might resemble a stylish striped design is, in fact, a progression of practically equal groups of clouds that should be visible even through small telescopes. These groups range in color from white to blue, and specialists recognize the lighter zones and the darker belts. And keeping in mind that the zones are essentially cooler and denser than their counterparts, they also contain rising gases give their lighter tone, which is reasonable because of ammonia ice. However, why the belts appear significantly darker is not yet fully understood. In general, scientists believe that phosphorus, sulfur, and maybe even hydrocarbons are present in them. Surprisingly, the researchers have observed a cyclical color change in the prominent bands every 4 to 5 years, which might be connected with cyclic motions of Jupiter's magnetic dynamo. Moreover, the zones and belts are limited by so-called jet streams, which race over the outer planetary layers at wind speeds of about 300 km per hour, compared to the speed of the Great Red Spot. That being said, the largest storm in the entire solar system actually moves at speeds of up to 680 km per hour. It is still unknown which chemical components are responsible for the red hue that gives it its name. What is known is that the enormous anticyclone is currently around 1.5 times the diameter of Earth and has been raging on Jupiter since at least 1830. By comparison, the wind vortices in Earth's atmosphere typically last for only a few weeks. Despite its impressive age, the Great Red Spot has now contracted considerably. While its length was still estimated at 40,000 kilometers during the 1880s, it is now only about 16,500 kilometers. NASA thinks this is due to interactions with other smaller storms. Could its own decrease in size also be the reason why this gigantic structure is literally shaking? Perhaps not. However, novel observations with the Hubble Space Telescope have recently shown that the Jupiter storm changes its appearance several times during its 90-day movement from east to west and back again. The Great Red Spot, on the other hand, shrinks and expands as it floats faster and slower. These motions also coincide with periodic variations in the size and brightness of the storm's eye, which are, however, negatively correlated to the drift rate. In fact, the Great Red Spot and its eye are at their largest and brightest when the storm is drifting at its slowest. The trademark changes a little from day to day, and over time, it looks as though the Great Red Spot is shaking like a leaf. But why is that? Well, we don't know. However, this is the first time that such swaying has been observed in a Jovian storm. The researchers have yet to provide the corresponding hydrodynamic explanations, but the speculation will only relate to the interactions with the fierce shear winds of the storm bands north and south of the Great Red Spot. What will happen next, given the past decreases in size? What are the chances that this massive structure will one day completely vanish from the Jupiter scene? Well, this is precisely the question that scientists are currently addressing. They now need to find out in detail whether there is a lower size limit beyond which such a seemingly perpetual typhoon becomes unstable. Thank you for watching this video. I hope you enjoyed this journey into the mysteries of the universe. If you found this video interesting, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel for more amazing updates.